Welcome all, welcome back at C-Square. In this lesson we'll talk about transformation. In fact, we're going to talk about rigid transformation. But first of all, let's see a transformation maps a figure, which we call the pre-image, in another figure, which we call the image. You're going to see that in this lesson. And I mentioned rigid transformation. They don't change the object, they keep the shape, they don't do any change of the shape. And we can hear those names also: rigid motion, congruent transformation, because the shapes are congruent, or isometry. And this transformation preserves the length of the segment and the measure of the angles. We have three of them: translation, reflection, and rotation. We're going to see them in this lesson. And this one is a translation. You notice how the pre-image A, B, C is moved, is slided, and we get the image A prime, B prime, C prime. This is a notation in case you never seen, and it was very good when you talk about transformation because it shows you the corresponding points. Now this one is a reflection. We reflect triangle ABC over this line. Let me call line M, and we get the triangle A prime, B prime, C prime. This is the image. And the last one will be obviously the rotation. Triangle ABC is rotated around, let's say, this point R, and we get this triangle A prime, B prime, C prime is rotated a certain angle. I can see that angle, something like this here. Okay, so now let's take a look in this, what I said. I mentioned that translation and the other two also preserve the length and the angle. You can see that here. This statement says exactly what I said, that AB and A prime, B prime, they have the same measure. These two, the same measure. And obviously these two the same measure. So yes, the translation preserves the lengths, preserve the angles, because this angle A is the same with this angle A prime, this angle B is the same with angle B prime, and this angle C is the same with C prime. Now this statement here tells you that we move the same amount the vertices of triangle ABC, and this amount is shown by this vector you see here. This is a notation you may see which says the translation of triangle ABC, the result is triangle A prime, B prime, C prime, and this is another way to see what I said. Triangle ABC becomes triangle A prime, B prime, C prime. Very similar, we have notation for reflection. You see here, triangle ABC becomes the triangle A prime, B prime, C prime. A reflection over the line M of triangle ABC is triangle A prime, B prime, C prime. Now property, remember, preserve length and angle. That's when we see how it preserves the length of the triangle ABC, and this is the angle. Another thing that I did not mention here, this line of reflection, how we call, is perpendicular bisector on these segments, in case you need that. Every single point you can construct by trying the perpendicular from the point to the line of reflection, and then make a congruent one on the other side, and you have A prime. The same for B and B prime, and C and C prime. Rotation, another transformation I mentioned. Notation here, triangle ABC becomes triangle A prime, B prime, C prime. Rotation of a number of degrees, you see it here, of triangle ABC. The center of rotation also needs to be mentioned. gives you the triangle A prime, B prime, C prime. Now let me mention that you can see a switch in some textbook. Sometimes they use the capital R for rotation and small r for reflection. This is the statement that shows that it preserves the length, so AB congruent to A prime, B prime, BC congruent to B prime, C prime, and AC congruent to A prime, C prime. And also preserve the angles. If you remember, is a congruent transformation, a rigid motion, an isometry, and now you can see what I said, okay, in the last thing. So now let's do some problem. Identify the type of rigid transformation shown below. So here we're going to look from the black image. So let's say black picture. Black is the pre-image, and red is the image. So how do I go from this guy to this guy? And obviously I think you can see it. That will be a, if you set rotation, that is exactly what it is. You rotate this black trapezoid and something like this. That's one way by the weights, and get on top of the red one. What about B? On B, this is a little bit tricky because we can have two transformation. Some people may say reflection. Okay, if we reflect this guy over the y-axis, we get this guy. But also it can be a translation. So either way, in this case, on part C, obviously we have only one way to get the black quadrilateral on top of the red quadrilateral, and that will be a reflection over this x-axis. And the last one, D, that will be a translation. We have to slide these guys something like that to go on top of the red one, the black on top of the red one. So that will be a translation only. And you notice here we move a little bit to this rigid transformation in the rectangular grid, which is probably the main objective of this lesson. So that's the thing I said here. All these rigid transformation can be represented verbally or using coordinate rule. And we're going to start with the first one, translation, where we have a couple ways, a verbal way, an algebraic way to represent translation. And also you may hear something that we call a vector. You see, remember that segment like with an arrow, that's the vector. We can represent it in this way. Let's see in this example. Write the coordinate rule for a transformation that translates the point xy 2 units to the left and 3 units upward. So I'm going to show you what usually I do. I'm looking to this 2 units left. Whenever you set 2 units left in the vector form, that means -2, you're moving to the left, and 3 units upward, you're moving up. That is +3. So remember this, left will be a minus, right will be a plus, and that goes with the axis. Obviously, up, and let's start down means negative, and up means positive, and that goes with y. So you see that now here, I move left, -2, it's right here, I move up 3, and that is the vector notation. which then we have the algebraic way x plus -2 or just x minus 2 will be good, and y plus 3. And that's it about this problem. You see all type of representation of this verbal statement. 2 units left and 3 units upward. So now let's see this example here where we have a quadrilateral, and the quadrilateral has these vertices, and we need to translate it by the vector 7 to write the coordinates of the image. So let's start with P. P has the coordinate -8. Sorry, -8 and -4, and we want to move it by the vector. So I'm going to write that vector. I think this is the easiest way here to go with. Okay, 7 and 2. So that will give us the P prime, which will be -8 plus 7 and -4 plus 2, which means this P becomes what? P prime, which is -8 plus 7, -1, -4 plus 2 is -4. That's it for P prime. Very similar, we're gonna do R. If you notice, R is -7, -1. Again, I'm gonna do that vector, which is 7 and 2. That means I'm gonna add, for getting the R prime, I'm gonna add 7 to the -7, and I'm gonna add 2 to the -1. So what will be the final answer in our case for point R? That will be 0 and 1. Okay, let me erase this -1 a little bit to be clear. Let's move to the third point of the quadrilateral, which is point S, which is -2 and 1. I'm gonna move, by the way, this means what? 7 right, 2 up. You may want to remember this, you never know. Now I'm gonna do the math right away. I think we can do it. -2 plus 7, that will be 5. 1 plus 2, that will be 3. And then we have a last point, which is the -1, -3. Okay, the same translation, which means what? 7 right, 2 up. Good to see that also graphically. -1 plus 7, that is 6, and -3 plus 2, that is -1. Okay, and that's it for this problem. You can see a little bit of a graphical approach here. This is the original guy. You see the coordinates, and this is the new guy. And I'm gonna just check it a little bit. Yeah, P prime is good. R prime, oh, I think I missed the R prime, maybe. -1 plus, no, we're good. It was right here, I'm sorry. S prime, we're good, and T prime is also good. And this is the vector, by the way. Okay, you don't really have to make that vector to draw, but just an idea to see this movement, this translation. Reflection is, like I said, another rigid transformation, and it can be described using coordinate rules. And we have some classic easy reflection here. Well, the first one is reflection over the x-axis, and you see the rule there verbally, and here is algebraically also over here. Okay, so what does it mean? You notice x stay the same when you reflect over the x-axis, the y change the sign, that's the meaning. Reflection over the y-axis, very similar. Let's take a look. This is the algebraic way to see it. In this case, x change, y stay. So that is a reflection over the y-axis algebraically. You can do graphically, and you'll see me probably. I'll do one example for you to see how to get the rule if you do not remember the rule when you take a test. Like in this case, right? Example. Triangle ABC has the vertices A, 4 and negative 2, B, 3 and 4, and C, 7 and 2. Triangle ABC is reflected over the x-axis. Let's say you do not remember the rule that I just mentioned. Take a point like A, 1, 2, 3, 4, 1, 2. This is the point A, 4 and negative 2. And reflect it over the x-axis, which is this horizontal line, and that means A prime is going to be 1, 2. So you see I count 2 units from A to the x-axis, and 1, 2, and A prime will be here, and that will be 4 and positive 2. In this moment, I think you should see the rule x, y, in this case becomes what? X stays, y change the sign. So this is the thing I'm gonna do now for every single point. For A, I already did it graphically. 4 and negative 2 becomes, and let me write that rule here. I'm gonna write it on the side. A prime is 4 and positive 2. So the rule says, let's put it this way, I think it's better. Xy becomes x and negative y. Point B, which is 3 and 4, becomes B prime, x stays, y change the sign, negative 4. The last one in this part A with point C, 7 and 2, C prime becomes what? X stays, y change, in this case becomes negative 2. And that's his part A. Part B, it's reflected over the y-axis. Okay, so again, if you do not remember the rule, make a picture. Was point A, 4 and negative 2, and it's going to be reflected on the other side. Okay, so that will be what? Now x switch, y stays. Okay, so let me write that rule here. X, y becomes, so like I said, x switch, y stays. And when I said switch, probably I should say change the sign. Change the sign maybe is better than switch, because I'm gonna use that word for a different reason. Okay, but let's take a look to our problem. So we finish. Let me write the coordinate to be sure. A, which is 4 and negative 2, becomes A prime, which is negative 4 and negative 2. B, which is 3 and 4. Again, what's happened here? X, change the sign, negative 3, and y stays. C, which is 7 and 2. What's happened here? What's happened here? Again, exchange the sign and y stays. And this is for this problem. You see the algebra behind and you see the graphical portion. This is the triangle we start from. This is when we reflect it over y-axis, the last part, and this is the first part when you reflect it over the x-axis. Be familiar with these graphical things also. You never know when you have to identify transformation, and there you go, you can see them here, this example. So this one is a reflection over the x-axis. Rotation, the last rigid transformation, isometry, congruent transformation. Remember, you have to have what is called a center of rotation and an angle that you rotate. And for special rotation today, we're going to talk about first rotation, 90 degree counterclockwise, which is the same with 270 degree clockwise. These two rotation, we call them equivalent rotation. Okay, it's right here. You notice here we rotate 90 degrees, and this one is counterclockwise. And is the same, is equivalent to this one, which you already see it, which is 270 clockwise. These guys are equivalent rotation, and this is the rule, and that's the reason I'm going to use here the word switch more. So if you notice here, we start from xy, and that well, the first thing you can do is to switch x and y and then change the sign for y, or you can change the sign of y and then switch it. I think that's what he says here down on the bottom. Okay, so this is the rule, but we have two more rotation. Another one is 180 degrees counterclockwise is the same of 180 degree clockwise. You will see it here is the, I think, the easy one in rotation. One more time, 180 degree counterclockwise is the same of 180 degree clockwise. The rule, xy becomes negative x, negative y. Don't switch x and y, keep them, just change the sign. And the last one is rotation 270 degree counterclockwise, which is the same equivalent of 90 degree clockwise around the origin. All these are around the origin, if I didn't mention that. It's right here, and you see it. Point A is rotated 270 degree counterclockwise is the same of 90 degree clockwise. This is the rule. Switch x and y, change the sign for x, or if you want to say change the sign for x and then switch it, that's also good. So let's see a problem. Let's see this example where we have these 3 points A, B, and C. We rotated 90 degree around the origin. And when this is not mentioned, that means you go counterclockwise. If it's not mentioned, that means you go counterclockwise. I do not remember the rule. Let's say you're taking a test and you do not remember the rule. Take an easy point, and sometimes I will say make everything positive, right? Like these points, let's say 1, 2, 3, and 1, and let me call it T, and I'm gonna rotate this guy 90 degree counterclockwise. So this is 3 and 1. That will be somewhere here, right? I hope you agree with me. T prime will be negative 1 and 3. So now you can see pretty much the rule. X, Y, what do I have to do here? Switch them. Leave some space. So you see how I switch x and y, and then which one changed the sign? If you take a look, the y will be a negative, right? So that's the way I get the rule. The rule was I think right here, right? Yeah, and in case I do not remember. So that means a prime will be what? We're gonna leave some space because we need it. Switch them first, -2 and 1, right? So you see how I switch x and y, and then change the sign of y. In this case, it was a negative, make it positive. Now we don't really need that plus, so I'm gonna erase it. But that's it for this first point. Point B. 5 and -3 becomes what? B prime. Again, I'm going to leave some space here. The first thing I'm going to do, I'm going to switch them, -3 and 5. So you see, I just copy, but I just switch them. And then I'm looking, oh, I need to change the sign of y is a negative, so that becomes a positive. So no reason to put that sign there. C, which is 3 and -5, becomes C prime, and what we're gonna do here, we switch them, and then we change the sign of y, which is this one stay positive. And that is part A. Oh, one more thing, determine the coordinate we did, and find an equivalent rotation. The equivalent rotation is 270 degree clockwise. Okay. Part B, rotate the triangle ABC 180 degree around the origin. I think this is the easy one. If you remember, if you do not remember, go back in the lesson. XY, they stay the same, they just change the sign. Okay. This guy, point T, is gonna be somewhere here, and he's gonna change the sign. There will be a rotation of 180 degree. So let's see what's going on here. A, which is 1 and -2, becomes A prime, which is going to be -1 and +2. Just change the sign. Don't switch them. B, which is 5 and -3, becomes what? B prime, which is going to be -5 and +3, and C, which is 3 and -5, becomes C prime, which is going to be -3 and +5. And let's go to the last one. Oh, one more thing. This rotation is equivalent to 180 degree clockwise, and again this one means counterclockwise. The last part, part C, we need to rotate the triangle 270 degree, and remember this means counterclockwise if it's not mentioned around the origin. Very similar. You may want to do a point, this point T. What is that guy? That's going to be somewhere here. Oops. And I know I didn't do a very good job here. But if this point is here at 3 and 1, you rotate it 270 degrees, going to be somewhere here. And what will be that guy? That guy will be 1 and -3. So what's the rule? XY becomes y and -x. So switch them, decoordinate the position, and change the sign of x. Okay, so now let's take a look to our problem. A, which is 1 and -2, becomes what? A prime. I'm gonna switch them, and I need to change the sign of y, so that means this becomes negative. B 5 and negative 3 becomes B prime. Again, what do we want to do here? We switch them. Be sure you have some space left and change the sign. Two things, right? Switch and change the sign. C, which is 3 and negative 5. What do we have to do here? Switch them and change the sign for the X. And that's it for this problem. You can see this transformation here, original triangle rotated. You notice this one is rotated either this way, this way 270 degrees or this way 90 degrees. Very similar. This one is 180 degree either way, and this one is 90 degrees this way and or 270 degree this way. Okay, and it's good sometimes to see how this rotation looks on the graph. Some more problem involving these things, and I said here, this transformation, sometimes you need to identify or undo the transformation, right? So in this case, triangle ABC is translated by a vector HK, and triangle A prime, B prime, C prime is shown below. So this triangle you see here is the image. Okay, part A, find the coordinate for this transformation if A is at the origin. So A was right here, the origin, and now it's right here at -2 and -1. So how do I go from 0 and 0, the origin, to this point, -2 and -1? 0 minus 2 will be -2, and 0 minus 1 will be -1. So this is the vector. This is this guy, something like this. That will move left 2 units, down 1 unit. Okay, so if you want to write a rule, that will be an algebraic rule instead of a vector. That will be this: x minus 2, y minus 1. Be familiar with both. Part B, find the coordinates of B and C. So B, I don't know what B is, but I know it was moved 2 left and 1 down, and B prime is, if you take a look, this is B prime, and which will be what, -6 and -2, right? So what should I do to this x coordinate? Then I subtract 2 and I get -6. That will be -4, doesn't it? -4 minus 2 is -6. And the very similar with the y. What should I do to this guy, to this y? Y minus 1 equals -2. How much is y? So you can even write equation if you want. Okay, so and that will be what? -1. -1 minus 1 is -2. Okay. Sometimes you may want to think backwards and say, hey, what is the vector that is undoing this vector? And that will be the opposite, 2 and 1, and add 2 here and add 1 here. So that is another way to do it. And let me show you that way, I guess. Also, C, it's the guy we need to find out. And I'm gonna write here -2 and -1. This is the original vector. I want to undo the guy. C prime, which is this point here, is what? -4 and 3. Okay, so whenever you want to undo, you may want to think backwards, and that will be this way: add 2, add 1. So I'm gonna do -4 plus 2. That is -2, right? -3. I'm sorry, +3 plus 1. That will be +4. Okay, and then you double check. -2 minus 2 is -4. 4 minus 1. Yeah, that works fine. So multiple way to see it. Maybe you can even do graphically in case that works for you. But that's it for this example. Let's take a look to this one. The vertices of triangle ABC are given, and also the vertices of triangle DEF are given. Identify the possible congruent transformation for what we see here. And let's take a look. You notice here, sometimes you don't have A prime, B prime, C prime, of course, because other than that, you know how to match the thing. But in this case, A is matched with D. Why? Because if you notice, A is the first one here, D is the first one here. And I'm taking a look to D now. So A is -2 and 1. You see it, and D is -2 and -1. Okay, one of these transformations we talk about in this lesson is doing this thing. XY, right? A becomes what? X and -y. Okay. In fact, you may want to look to the others if they follow the same thing. B, which is 5 and 3, does it follow the same rule that I mentioned before? You may want to see that B goes with E, and that is 5 and -3. It does, right? So if you take a look to C and F, I think they do follow the same thing. 2 and 4 becomes F. 2 and -4. So if you do not see, if you do not remember all those X, Y's, and guess what? You may want to do a picture like I did it here. And then you see it. This transformation is nothing else than reflection over X axis. So you can do it graphically, and then you really don't need to put all 3 points. Sometimes only one is good enough. Maybe you want to check with a second point. I will do that. And that's it for that problem. Let's take a look to this problem. Samuel rotate quadrilateral A, B, C, D 270 degree. Doesn't mention, so that would be counterclockwise about the origin, and he gets the new guy: A prime, B prime, C prime, D prime, which you see here. Find the sum of the wall y coordinate. So let's try to do here. So A, which I do not know, becomes A prime, which is 1 and 5. And we have this rotation of 270 degree counterclockwise. What is the rule for that guy? Do you remember the rule? No, we do not remember the rule. Again, I'm going to do a point. Let's say T. Again, I'm going to go in the first quadrant, 3 and 1. Be sure they are not the same. This is point T, 3 and 1. Now I'm going to rotate 270 degree counterclockwise. So this way. So the point is going to be right here. That's going to be a 270. And that will be T prime, which will be 1 and -3. So what is the rule in this case? X, Y becomes, we switch X and Y, and we change the sign for X. Okay, so now we know that should be the rule to go from A to A prime. But unfortunately, I need to go the other way from A prime to A, or fortunately, because I have the A prime, B prime, I have the C prime and D prime. So if you want to do that, you have to think backwards, right? So how do I go from this T prime, which I'm going to call it now XY, to T, which is going to be what? Again, we notice we switch the guys, right? And now we notice this -3, which is the y coordinate here, right, becomes a positive, so we're gonna have this guy. So this transformation is undoing this transformation. Okay, so that's the one I'm gonna use now. Let me be sure. This one. Undo the transformation. 270 degrees clockwise. If I undo this one, that means I'm gonna do a what? 270 degrees. I'm sorry, this is counterclockwise. I'm gonna go a 270 degree clockwise or 90 degree counterclockwise. All right. Good. So now is this guy. So we have 1 and 5. We switch them, 5 and 1, and we're gonna change the sign to the y, which in this case is this 5. So this is the first guy. Now B prime, which is 1 and 0. I'm gonna undo using the red rule, let's say like that. And what do I have to do? Switch 0 and 1 and change the sign of the y, which in this case is just this 0, right? No reason to change it. C prime, which is -1 and -1. Okay, what will be the C? Again, I'm going to use the red rule, like I said. I'm going to switch the X and Y, in this case nothing, pretty much, because both of them were -1, and I have to change the sign of this Y. That will be a positive, so I'm going to change the sign here. And we have our last one, D prime. D prime is -3 and 3. We're gonna switch this guy, we're gonna get D again. And we switch X and Y, 3 and -3, and then change the sign of this Y, -3. Okay, so that's it. If you look to the transformation, however, I said here, find the sum of all y coordinate of this original guy. So what we have to do here is to add the y coordinate, right? 1, -1, -3. So 1 plus 1 plus -1 plus -3. If you want to put it like that, these two guys cancel out, so we have 1 plus -3. That will be -2 in this case. Let's see a little bit of a graph. Oops, let me erase that side where I put all these rules. And this is the A prime, B prime, C prime, D prime is the original, the image. Let's be consistent of the lesson. And this is the result of rotating this guy A, B, C, D 270 degree counterclockwise. And you can see that in the picture. These are the guys we found out. we can double check graphically A, -5 and 1, B 0 and 1. This is the guy, you know, that's interesting, right? C 1 and -1, and D -3 and -3, and we did it like you saw it in this lesson. That's it for all this lesson today. Thank you for watching, and don't forget to click the like button and come back and C-square for more help. Thank you.